trigonometric ratio for angles greater than 90 degrees. So what do we have here on the diagram? You'll see two triangles, the one in blue, OAP, and the one in red, OA prime, P prime. These two triangles are congruent, which is indicated here. So what that means that corresponding sides are of equal length. And triangle OAP was selected randomly, so there is no particular value for angle alpha that we have selected. So this is just a triangle arbitrarily selected. So this triangle here defines angle alpha in green, and our focus will be on angle theta, and we will have to define sine ratio for theta, cosine ratio, and tangent ratio. So let's start with sine theta. Sine for angle theta. In order to find the ratio for angle theta, we will use this red triangle where angle alpha is called related angle, related to angle theta. So the same ratio will be used as the ratio for angle alpha to find the ratio for the angle theta. So sine is defined as opposite over the adjacent, opposite over the hypotenuse. So this is y. We'll say y over r. And please note that y is a positive reading in this second quadrant, and r has positive reading. There's a distance between 0 and p prime. So for the sine ratio, we'll have y over r for any angle that is greater than 90 and less than 180 degrees, or you can call it greater than pi over 2 radians and less than pi radians. Cosine ratio. Cosine ratio. So once again, we will use the same angle theta, and this angle theta has a related angle alpha. So cosine for the first quadrant is defined as adjacent over hypotenuse, so x over r. So by the same analogy, the ratio for angle alpha in red will be defined as negative x, because we're using Cartesian plane, so negative x divided by positive r. So this is negative x over r. So the difference between first quadrant for cosine ratio remains positive here, because we have positive reading for x value and positive for r, whereas here we have negative reading for x value and positive reading for r. Tangent of angle theta. So for the first quadrant, tangent is defined as opposite over adjacent, y over x. So for that angle theta, the related angle that we will use is angle alpha. So the ratio will be determined by y as opposite divided by negative x. So you will see y over negative x. So in quadrant number 2, the only positive ratio is sine. So sine is positive. So we're going to mark as positive. This is important for us to remember that. So cosine and tangent are negative ratio. Moving down to quadrant number 3. So our angle theta is defined between positive part of x-axis, so from this point all the way up to here. So in quadrant number 3, we have a triangle O, A double prime, P double prime. And this red triangle is congruent with the triangle OAP. So this is why that green angle alpha here is reflected in the origin as the one over on that side. So the corresponding sides are of equal length in terms of absolute value. So this measurement is equal to that on this side. Along x-axis, this measurement is equal to that. So for y ratio, for sine ratio, sine of angle theta, we know that from the first quadrant, the definition for that is opposite over the hypotenuse. So since alpha in red color now is the corresponding angle for angle theta, so the ratio sine will be defined as negative y over r. Why negative y? Because the coordinate for that vertex P double prime is defined as negative x and negative y. So the distance is considered negative here. So sine ratio is negative now in quadrant number 3. Cosine ratio. Cosine ratio, recall from quadrant 1, this is the ratio of x over r. So for angle theta, by the same analogy, alpha, angle alpha here is the related angle, and the ratio is adjacent over hypotenuse, which is negative x over r. Tangent ratio. Tangent theta from quadrant number 1, opposite over the adjacent, so opposite over adjacent, negative y over negative x will result with positive ratio y over x. So in this quadrant, tangent ratio is positive. And the angle theta here in quadrant number 3 is the angle that is greater than 180 and less than 270 degrees, or greater than pi radians and less than 3/2 pi radians. Quadrant number 4. So now our angle theta is contained between 270 and 360, or between 3/2 pi radians and 2 pi radians. Once again, we know for the first quadrant the ratio for sine, cosine, and tangent. And since alpha is the related angle for angle theta, so we will be using the red triangle to define sine ratio, cosine, and tangent. So sine of angle theta as traditionally opposite over hypotenuse. So this is y is negative. So point P triple prime has positive x and negative y. So this distance is considered as negative y over r. Cosine theta, same situation, use the related angle. So this is the ratio x over r. And tangent angle theta, opposite to negative y over the adjacent. So negative y over x. So in this quadrant, the only positive ratio is cosine ratio. So now let's summarize. In quadrant 1, all ratios were positive. Quadrant number 2, if you recall, sine ratio was positive. Quadrant number 3, tangent. And quadrant number 4. So let me write this one in front. So this way we'll create the cast rule. So this is the acronym that allows us to quickly identify in which quadrant what trig ratio remains positive. Thank you for watching this video, and I see you next time when we will be discussing cofunctions using unit circle. Thank you very much.